Hello everyone, welcome to this SQLAlchemy ORM crash course part 2. This is a continuation of the first part on this channel where we cover the basics of using SQLAlchemy ORM. In this video, we're going to cover more advanced features such as declare attributes on abstract models, outer joins, adding columns to models, average, sum, count functions, Coalesce, Case, labels for annotations, aliasing tables, and subqueries. If you've got experience with SQLAlchemy ORM, you can follow this video. However, if you believe that you need more knowledge, you can follow the first video as a prerequisite to this one. We've got a lot to cover, so without any further ado, let's begin. In terms of IDE, I'm using PyCharm Professional Edition. You can use any IDE of your choice, but if you want to use this one, head over to jetbrains.com/pycharm/download, and there are versions for Windows, Mac OS, and Linux. There's a Community Edition and a Professional Edition. The Professional Edition has a few more features such as the database viewer I'm going to be using in this video. So, here we're on a project and we've got our project folder and we've got completed and start, as well as poetry and pyproject.toml, which is our dependencies. So start is where we're going to start and contains all the code. That is the starting point of where we're going to start this tutorial, and completed is where we're going to end up at the end of this tutorial. First of all, we're going to head to our terminal and we're going to activate our environment because we're using virtual environments, because we don't want to use the Python global interpreter on our machine. So I'm going to do poetry shell, and that creates a new virtual environment, and now I'm going to install my dependencies. So I'm going to do poetry install. And I've got two of them, typing extensions and SQLAlchemy. Okay. So if we go into pyproject.toml, you will see we've got these dependencies here. So we've got SQLAlchemy, the other one was a dependency of SQLAlchemy. Okay, so if we close this, now we're ready to start. We're going to head to start, we're going to go into our models, and we're going to create another Python file. We're going to call this drive. And the reason we're going to call this drive is because we're going to create a drive model in it. A drive, I mean, as a drive in a vehicle. Essentially, our application will simulate that our users have many drives. So this could be a vehicle tracking application or something else. So the reason we chose this is because it has a few layers to it, and we can use the various SQL functions to do some aggregations. So let's start by declaring our drive model. So I'm going to say drive, and then here I'm going to extend from timestamped model. We're going to, okay, I'm going to import that. Okay, so we're going to configure our Python interpreter because PyCharm is complaining. So we're going to add a new interpreter. We're going to go to add local interpreter. We're going to go to poetry environment, and we're going to use the existing one, the one we just activated. So I'm going to click OK. And now that that is done, PyCharm is scanning for the packages. So I'm going to import my timestamp model from start.models. Okay. For now, I'm going to do pass. And the reason is because I want to show you what is the timestamp model, because you might be wondering. So this comes from the base. So here, base. So timestamp model is an abstract model which defines two columns, created at and updated at. So the first one gets created once you create an entry in a model that extends this model, and the other one creates an updated timestamp once you perform any update operations on that model. So here we're going to add the name of the table. So we're going to say table name, and that will be drives. And the reason I'm overriding this is because by default, SQLAlchemy uses the singular of, so essentially it uses the class name lowercase. So that would be drive if we didn't override it. And I like to use plural, but feel free to use what you like. So here I'm going to have a column named ID, which is going to be our primary key. So we're going to say column, and we're going to import this from SQLAlchemy. So here we're going to say what type of column this is, and here we're going to say integer, and we're going to import that again. Great. And then we're going to say this is our primary key and set it to true. And then auto increment, we're going to set that to true because we want the primary ID to auto increment. We don't want to set it. Okay. And here we can declare a few other foreign keys. I'm going to start with the user ID. So I'm going to say user ID is equal to a column. It's an integer column and it's a foreign key. So we're going to say foreign key. We're going to import that. And essentially we're going to say, where does this point? So it points to the users table and the ID. So the primary key. Here I'm going to say on delete. And here I'm going to say cascade. So what this means is if you delete the user, delete the drive as well, because we don't want any orphan records to exist in our database. So we can finish with this. And here we're going to say that our column is non-nullable. So we're going to say nullable is equal to false. And then we're going to say index is true. So nullable means you need to add it. And the reason we need to add it is because we want each drive to belong to a user. And index is for performance purposes. Okay, so we have the user here. Now we're going to go on the user model and we're going to create a relationship. So before we go here, we can create the relationship here. So we're going to say user is equal to relationship. We're going to import that from SQLAlchemy ORM, and this will be user. And this is essentially the name of the model. And here we're going to say back populates, and this will be drives. So what this means is there's got to be a key on the user model called drives, and that's got to be a relationship. So essentially it's the reverse relationship. So if we go here and we come here, we're going to say drives, which is what I just told you. And here we're going to say relationship, and here we're going to say drive, which is the name of the model. And here we're going to say back populates, and we're going to say user. Okay, and the user, this is what is here. Okay, so now that we have this, we need to have a few more attributes on the drive. So we need to have a distance, an economy, a duration. But those need to be models of their own. And the reason they need to be models of their own is because they have a value as well as a unit. Okay, so what we're going to do is we're going to head to our models and we're going to create another file. So we're going to say new Python file, and here we're going to say data. Okay, so in our data, we're going to create our unit. Okay, so we're going to say class unit, and this is a time stamped model. So we're going to import that. Okay, and here we're going to say that the table name is units. Okay, now that we've got this, we want an ID, which is going to be our primary key. So we're going to say column, we're going to import that, and we're going to say that this is an integer. So we're going to import that as well from SQLAlchemy. And here we're going to say it's the primary key, and auto increment should be true. Now we need a name. And we're going to say this is column, and this is a string. So we're going to import that from SQLAlchemy again. And here we're going to specify the length of the string. So I think 40 characters should be enough. So I'm going to say nullable equal to false because we want this to be a required field. And here I'm going to have slug. Okay. This is going to be again 40 characters. Nullable is false. And there's an additional parameter which is unique and will be true because we want our units to be unique based on the slug. Okay, so now that we have that, we have one more thing we need to do. So we're going to create the metrics model. And this will extend timestamp model. And this will be abstract. So what is this? So this is essentially a model that can be used by other models in order to define some specific metrics. So for example, we could have the duration, we could have the distance, and they could all extend this metrics model. So let me just add a few columns and this will make more sense. So we're going to say column, and here we're going to say integer is our primary key again. We're going to say auto increment to true, great. And then all our metrics models, we have a value, okay? So we're going to say column, and here we're going to make this a float, okay? And we will have a unit ID. Okay, we're going to say column, integer, and then we're going to say foreign key. We're going to import that. And this will point to this table here. So units, that's the name of the table. And then it will point to the ID. Okay, so now that we've got this, we're going to say that this is required. So nullable is false. And then we're going to say index to true. So we have faster operations. Okay, so now that we've got this, what we normally do is we define the relationship. So I would have normally done a unit is equal to a relationship. And then I would have said unit. Okay. However, this doesn't work on abstract models. So the workaround and the recommended way from SQLAlchemy is to create a function. So we're going to say define unit, which is our function. We're going to have self here. And here we're just going to return this relationship. So we're going to say return relationship unit. However, on its own is not enough. It needs a decorator. So this decorator comes from SQLAlchemy and it's called declared attribute. So we're going to say declared, and attribute is short, ATTR. So we're going to import that from SQLAlchemy ORM. So now that we've got this model is finished. So now we want to define the concretion. So essentially the actual implementation tables that are going to use this abstract model. So we're going to say class distance, because we said we want a distance for our drives. So this will extend the metrics model. And here we can give it a name. So we can say table name is equal to distances. And then what do we need to define here other than this? Well, we don't need to define anything. And the reason we don't need to define anything is because the distance will have a value and the distance will have a unit. So the only difference on these models will essentially be the name of the table. We could have had a polymorphic table, but essentially for performance purposes, it's better to have individual tables. So I'm going to copy this just for simplicity's sake, and I'm going to call this economy. and then I'm going to call this economies. Okay, and then we have one more. We said it was going to be the duration. Okay, so now that we're done with this, we need to create the relationships. So now that we have defined all these modules, let's wire them together with the drive. So we're going to go to the drive, and here, exactly like we had for the user ID, we're going to do it for the distance, the economy, and the duration. So I'm going to go here, and we're going to say distance ID is equal to a column. And here we're going to say it's an integer, and we want it to be a foreign key, which is going to point to distances.id. Okay. And what we want to do is we want to say nullable false, because we want it to be required, and index to true. So I'm going to duplicate this a couple of times, and here we're going to say economy ID. And here we're going to say economies. And here we're going to say duration ID. And here we're going to say durations. Okay. So what we need to do here is we need to create the relationships for these models. So here I'm going to say that the distance is equal to a relationship, and this will point to the distance model. I'm going to duplicate this a couple of times, and I'm going to say economy. This has to be economy, and this one will be duration. So we're going to say duration. Okay, so all of these are defined now. Now we are ready to create our database table. Okay, so we're going to go to the terminal. We're going to say Python 3. And what we're going to do here is we have to essentially import our models, and then we have to create the database. Okay, so before we do that, just to save some time, we're going to go into the models and the init. We're going to duplicate that a couple of times, and we're going to say data, and here we're going to say drive. So essentially we're importing all the modules in our init file. So when we import them here, we only have to import the modules. So I'm going to exit the REPL and open it again. And then here I'm going to say from start.modules, import everything. And then I'm going to say from start.main, import the engine. So if you're wondering what that is, it's this thing here. It's the database engine we created. It's the SQLAlchemy SQLite database engine. Okay. So now that we've got this, let's close this. We're going to say model, which is our base model. And we're going to say metadata. And then we're going to say create all. And then we're going to pass the engine in. And then we're going to create them. Okay. So now we can head here. We can say data source, SQLite, and here we can point to the file. So okay. So that one there. We're going to test the connection. Okay, it works. We're going to apply. Okay. Okay. So if we go here, got the main, we're going to open that, we're going to refresh, and we've got 11 database tables. So if we look into the users, there's no users. So what we need to do is we need to seed the database. We've got this seed file here, and we've got a lot of data. This was from the previous tutorial, but we need to add a few more things. So I'm going to put this on the side. I'm going to go to completed just to make it a bit easier because we're just going to be copying stuff. And then I'm going to explain what all this stuff means. So if we go to the top, we've got the unit data. Let's copy this. So this is essentially a list of dictionaries with a name and a slug. This is for our unit model. So we're going to populate our unit model with unit types. So the first two are for the distance. The second two are for the economy. And then the last one is for the duration. So if we go down, let's see what we're doing here. Let's go down here. So under rows, we're basically iterating over our unit data list, and essentially we're adding to the session a new instance of the unit, and we're unpacking the keyword arguments, which are name and slug. So what I'm going to do is I'm going to copy this and I'm going to paste it here, and we're going to import this. So we're going to import this name from the start. Great. And then we're going to go down here and we're going to copy all this stuff as well. So we're going to go here. And what are we doing here? We're essentially, after we've added them to the database, we're fetching them all. And then I'm fetching the mouse unit by filtering on the slug and then calling next on it to get the next item, which there's going to be only one. So I'm doing that for the mouse per gallon and minutes. Okay. So let's go down here. And what we're doing here is we've got drives and then we've got this thing here. So what's happening here? So what we're doing is we're checking if I, and I is the index of our enumeration of the user data list. So for each user, there's going to be an index. So the first user is going to be 0, second is going to be 1. Okay. So what we're doing here is we're saying if we divide by 2 and the remainder is 0, meaning it's divisible by 2, then do whatever we're doing here. So essentially it means for the first user, we're going to run this. For the second user, because the index will be 1, we're not going to do it, so on and so forth. And the reason we're doing this is so we can have some differences. So essentially we can have some users with drives and some without. Okay. So we're going to copy this, and the reason we're doing that is when we're doing the querying in the database, there's going to be some issues when we don't have drives, and we want to solve that by querying in a different way. So let's copy this, and we're going to put it under here. So let's import a couple of stuff. Okay, so we're importing all of our models. Okay, so what have we done here? We've essentially are creating a distance model that has mouse unit as its unit, and then a random choice for a value between 30, 300, the same for duration, economy. And then we're adding all of those to the drive. And then we're appending to the drive list, and then we're setting the user drives relationship to drives. Okay, so this is all we're doing. So go to the top. Here we need to specify from start. Okay, great. So we're going to close this file, and then we're going to close this file, and then we're going to open our terminal. And we're going to seed our database. So I'm going to get out of the REPL, and then I'm going to say Python 3, and then I'm going to run this as a module, and then I'm going to say start. And the reason start is because we've got here start, and then we want to point to seed. So I'm going to say start.seed. Okay, so we're going to run this. Okay, so this has added data to our database. So if we go here, we've got the users, we've got the user rows, units, durations, drives, all this stuff. So now we're ready to start querying the database. So we're going to go into queries, and here we're going to create a Python file and we're going to call it advanced querying. Okay. So now that we've got this, we're going to start querying the database and learning new stuff. So let's start by grabbing all the users from the database and adding some columns to it. So I'm going to say users with new column is equal to user. Let's import the user model. And here we're going to say query. Okay. Let's put the dot here. It's just a preference. And then we're going to say add columns. And I'm going to explain exactly what this does. And then here we're going to call on. So add columns adds an additional column in addition to the user model. So the user model is one item and each column addition will be added to a tuple. So the first item of the tuple will be the user model and then each subsequent item will be the column that we have added. So what can we do here? So I'm going to call column and this is from SQLAlchemy and I'm basically going to add the ID column. This doesn't make too much sense, but you'll see it's a starting point so we can understand what add columns does. So we're going to print, let's fetch the first user, okay? So we're fetching all the users here, but let's grab the first result. So I'm going to say users with column, and then we're going to access the first one, okay? And then, like I told you, the user model lives on the first item of the tuple. But before we do that, let's just print this. So if we run this, there you go, we get a tuple with the user model and then the ID. So here you might think this is a string, but this is the representation of the model. So if we go here and we say user, and then we're going to say first result, and then we're going to say 0 because that is the first item of the tuple. We can say user dot and then anything. So I'm going to say user dot first name. So if we run that, we get the first name of the user. However, if we want to get the user ID, which is what we added here, we're going to say user ID is equal, and then we're going to say first result dot ID. So like I said, the first item will be the user model, and then any subsequent item or column added can be accessed with the dot notation. So we're going to say first result dot ID. So if we print user ID, we get 1. For this example, there's no much point because we can get the ID from the actual user model. But you can see the why we would do this in the next example, okay? So if we go down here, we can comment this out. And then we're going to say users with their drive count. So we're going to say users with drive count is equal. Okay, so because this is going to be the same, I'm just going to copy it. Let's uncomment it. Okay, we've added extra stuff here. We don't need that. We don't need that. Okay, so here where we're adding columns, we're not going to add this column. We're going to do something different. So we're going to use a database function now. So we're going to say func, and then we're going to import that from SQLAlchemy.func. So we're going to say func dot, and then we're going to count how many drives this user has, okay? But in order to do that, we have to join to the drives table. So we're going to say dot join, and then we're going to say user dot drives. Okay, and here we're gonna say drive. I'm gonna import that model, and then just select any column. It doesn't matter because we're essentially counting the instances of this model that are joined to this user. And then if you want to add a name to this column you're adding, you can call label. And you can name it anything you want. So I'm going to say drive count. Okay. So we've got the users with the drive count. So if we print that, we run it, we get John Doe has 13 drives. So this seems a bit wrong because John Doe does not have 13 drives. And this is on purpose. And the way you fix this is by grouping. Whenever you have an aggregation, like a function that counts, averages, you need to tell it how to group things. So essentially we want to have the count of the drives per user. So here we're going to say group by, and then we're going to say user.id. So if we run this again, there you go, we get more users. So John Doe has 2, Bob Johnson has 2, David Kim has 7, Michael Davis has 2. But we have more users than that. So if we go here, we've got 7 users, but we only got 1, 2, 3, 4 results. So 3 users are missing. Well, the reason they're missing is because they do not have drives. So in order to solve that, because you want to get all the users regardless of if they have drives or not, and add the count, you got to outer join. Okay, we were joining. A default join is an inner join. An outer join is a left outer join. So essentially get me this table, so users, and then join the subsequent tables, and don't limit them if there's no match. So if we run this, we get way more users. And then we see Jane Smith, we get that person, and they've got 0 drives, which is what we want. Next example is the average drive distance, okay? So we essentially want to get the average distance driven by each user. So how do we do that? So I'm going to use this as a starting point. So I'm going to comment this out. So we're going to say users with average drive distance. So we want the user, query, outer join drives, and then we want to use another function. So that function is average, but we're not going to do average drive.id because that's going to get the average drive ID. That makes no sense. We want to get the average drive distance. So we need to perform a subsequent join. So I'm going to duplicate this and we're going to say drive. And here we're going to say distance, okay? And here we're going to say distance. We're going to import that. And we're going to say value. And here we're going to say average drive distance, okay? So let's print this and run it. There you go. We've got John Doe with 58, Jane Smith with none, Bob Johnson with none, then Alice Lee none, David Kim with 159.5, and so on and so forth. So what's happening here? So we've joined the user to the drives, the drive to the distance, and we're getting the average distance. However, we're getting a couple of nones. So what does none mean? So that person had no drives or no distances, and then essentially it gave us a none. And the way database systems works is they omit none values or null values when they're performing aggregations. So in this case, when we've got John Doe, it only gets their drives that are not none. So if we wanted to include those, we would have to do something else. let's get the average drive distance with zeros. So for example, here that we've got nones, we want to replace those with zeros, okay? So let's copy this. Let's paste it. So here we've got users with average drive distance, and here we're going to say or 0. Okay, so here is where another function comes into play, and that's coalesce. Okay, so coalesce is essentially a function that takes any number of arguments and then returns the first non-null argument. So let me explain. So we're going to say function dot coalesce. Okay, and then here I'm going to pass the average distance dot value. Okay, and then as a second argument, I'm going to put 0. So what does that mean? So I'm going to close this so we can see a bit more. It means get the average distance, okay? And if that's none, then give me 0. So if we get this and we print this, there you go. We've got 58, which is the same as before. And then Jane Smith, we get, instead of none, we get 0. Okay, so that's how you remove the zeros from the equation. Now, you could have, for example, okay, included in the calculation null drives. So drives that are null. So what do I mean by that? So for example, you might have drives that have, for some reason, not recorded the distance. But with this way, those are omitted and they're not calculated in the average. So your average would be higher. But if you included them, your average would be lower. This is business logic and it depends what you want to achieve. So I'm going to show you how we can do that as well. So here we've got users with average drive distance or 0, okay, including null. So how can we achieve this? Well, we kind of flip things over. So here we're going to say function dot average. So what are we going to average? We're going to average the distance. No, so here we need the coalesce. So we're going to say function dot coalesce, and then here we're going to say distance dot value, and then next to it we're going to put 0. Okay. What does this mean? I mean, it's a bit confusing. So let me explain. So essentially, it's taking, okay. So let me see. Okay, so this should have been there, and this should have been there. Okay, so let's look at it from inside to outside. So we're having coalesce of distance dot value or 0. So essentially, what this means is it grabs every drive distance and checks if it's null. If it's null, you get 0. So essentially, it won't be omitted from the average calculation. So it will include null drives with null distance into the calculation. And so you can see this. Okay, we're going to comment out this one here. So we're only going to run this too, so you can see. So if we run that, can you see that John Doe now has an average of 29? And the reason is because we included null distance drives in the calculation. Okay? So there's no right and wrong. It depends on your business logic and how you want to interpret that data. Maybe null actually means 0, or maybe it means it's corrupted. If it's corrupted, most likely you would remove it from the calculation, so you wouldn't do this. But if it means 0, then you would do something like this. Okay, so now we're going to move on to the next function, which is the sum. So we want to find the total distance driven. So how we're going to do that? So I'm going to copy this here as a starting point. And we're going to comment all of this. Okay. And we're going to go here, users with And here we're going to say total distance driven. Okay. So how can we achieve the total distance driven? So the way we're going to do this is we're going to have a sum and then we're going to coalesce to 0. So essentially, we're basically going to avoid the nulls. So what we're going to do here is we're going to leave this to coalesce, and then here we're going to say sum distance dot value or 0. So here we're going to say total distance driven. Okay, so let's run this. There you go. We've got John Doe with 58, Jane Smith with 0, Bob Johnson with 0, Alice Lee with 0, David Kim with 319. Okay, so let's have a look and see if this is actually right. So we're going to go to the database. We're going to grab John Doe. So John Doe is ID of 1. John Doe has, let's have a look, user ID. They've got 2 drives, 1 and 2. So if we go to their drives, distances of their drives, 1 and 2. So 58. So it's correct. So moving on, there's a way that aggregations like Sum can have biased results. So what do I mean by that? So let me copy this and I'll explain what that means. So I'm going to paste that here. So users with total distance driven. Okay, so we want the same thing. However, let's say, for example, you join the rows of the user. Okay, so here I'm going to say outer join user dot rows. Okay. And let's say the reason I wanted to join was so I could filter. Okay, so I'm going to run a filter here. And then I'm going to say row. I'm going to import that. I'm going to say .slug.in. And then here I'm going to pass a list. Okay. And then I'm going to say admin. And here I'm going to say super admin. All right, so this is complaining. However, I believe this is correct. So if we run this again, look at what has happened. So if we look at the previous result, it's 58, and here it's doubled, right? So if we go, this one is 319, it's doubled. So why is it doubled? Well, the reason it's doubled is because the way joins work is if you join a table that has a one-to-many relationship, essentially it multiplies the results. So it skews our results. So this is actually wrong, okay? So here we're going to say that this is wrong, so don't do it. So wrong, okay? And then essentially the values are calculated multiple times because of another join. Okay, how do we fix this? Because let's say we need to get the rows. Well, that's where the subquery comes in. So you can perform the aggregation on the subquery and then this on the secondary query. So I'm going to copy this and then we're going to make some changes to this. So first of all, we need a subquery, okay? So I'm going to say here, I'm going to say subquery is equal. And then what do we mean by subquery? So it's essentially the same as a query, but it can be joined later. So we're going to say user.query outer join. So essentially, let's just grab everything from here, put it here, except the rows. We don't need the rows. The rows, we're going to do the join here. And what we're going to do here is we're going to say with entities. Okay, So with entities essentially selects a subset of columns to include in the final result as part of a tuple. So we're going to grab whatever we created here. We need that. And then we also need something else. So we're going to say group by as well, because we want to group by the user ID. And then here we need another column. And the reason we need another column is we'll need something to join to later. So we're going to say user.id dot label. Okay, the reason is getting an error. We need a comma there, dot label. Okay, and then here we can name it whatever we want. So I'm going to name it user ID. And then here we're going to call subquery. So essentially this creates a subquery. Okay, it doesn't execute the query. It basically creates the SQL statement that we're going to join here. Okay, so we don't need this. We don't need this. We need this and this. We don't need this. Okay, we don't need this. So what we need to do is we need to perform one more join. So we're going to say outer join. And what are we actually going to join to here? Well, we're going to join to this subquery here. So we're going to say subquery. And then here, we're going to tell it how it should join. So we're going to say user.id is equal to subquery.c. So the columns on the subquery are held on a key called C. And then here we're going to put the column name. And we named it user ID, so we're going to put user ID. Okay? So that's how you perform the join. And now we want to get all those values from that join and add them to our main query. So how do we do that? Well, there's another function called add columns. So we're going to go here, and we're going to say add columns. Okay? And then what columns do we want to add? We could have done subquery.columns, and then we could essentially have unpacked it. So we could have done this, but we don't want to do that because we only want to join to, not join, we only want to include this one here. So I'm going to be explicit and I'm going to add it there. Okay, so this looks more or less correct. So let's run it. Okay, there you go. We got 58. Here we got 319. So it's correct again. And essentially we get the same result that we wanted to achieve, as well as joining with the rows and filtering. Okay. So we can have more complicated subqueries where we have different statements. So case statements are like an if-else statement, and we can use that within SQL. So let me use this as a starting point, and I'll explain what I mean. Okay, so here we want to get the average drive speed, okay? So users with average drive speed. We don't have the average drive speed or the drive speed in the database, so we got to derive that. So how do we do that? Okay, so the way we're going to do that is we're going to say, give me the sum of, let's have a look, the distance to the value, and then I would divide that by the sum of the duration. Okay, so we need to join by the duration, so drive.duration. And then here we're going to say duration.value. But our duration is in minutes, so we've got to get it in hours. So we're going to go here, we're going to say divide that by 60. Okay, so here we're going to call this miles per hour. Okay, so here we're going to say mph. We don't need this. We don't need this. Let's copy and paste this. If we run it again, there you go. We get the miles per hour. However, we get nones. So how do we solve the issue of getting nones? Well, quite easy. We get a case. So I'm going to copy this. So I'm going to say case. Okay, so case is an SQL function and it comes from SQLAlchemy. Okay, so we're going to say case, and then case, it takes a tuple of 2 items. Okay, so essentially the first item of the tuple is the condition, and the second item is to return if the condition is true. And then here we have another keyword argument, else, which is if the case is not true, then return this. So what we're going to do here is we're going to say function dot sum, and then we're going to say distance dot value. So we want this to be true, and we also want the duration to be true. So there's another function called end underscore. So we're going to import that from SQLAlchemy. And then this one takes multiple parameters. Okay, so we're going to put a comma here, and we're going to say function dot sum of duration dot value. Okay, so let's separate this a bit. So what we need here is, let's have a look. We need the comma. And then here we need another. Let's have a look. Let's put this there. And okay. We need another one here, comma. There you go. So this works fine. So this is the condition. And the second one is what we want to run. So we had this here. We essentially want the sum. We don't need this. Let's remove this. So the sum of the distance.value divided by the sum of the duration divided by 60. Okay. Let's have a look here. Okay, we don't need this here. We don't need that. Else, and then here is where we need the label. Okay, so this was a bit complicated, that's why I said this can get complicated, and then you join here. Okay, so if we run this, we get the zeros that we wanted. So that's how you use the case statement. So to recap that, we use a tuple. So this is the first item of the tuple, which is the condition. In this case, it was a condition of 2. So 2 things needed to be true. The sum of the distance value and the sum of the duration value needed to be non-nons. And then if that is true, you get this equation here. Otherwise, you get a 0. This first part you could have performed a bit differently. So you could have done like so. Let me put it like that. You could have performed it like this. Oh no, wait 1 second. There you go. So you could have performed it with an ampersand operator. Okay, so if you do that, it works the same way. Okay, it's a matter of preference. So what if we wanted to get the average drive speed? Okay, but we wanted to make sure that the unit was miles and the unit was minutes, both for the distance and the duration. So how do we do this? So let's just copy this. We can comment it out. All right. Then we can paste it here. So let's have a look. So we're joining the distance, the duration. However, we're not 100% sure that this would be correct, because what if we had kilometers and what if we had seconds, because they are declared in our units. So the way you do that is on the join. So here, if we want to join to the, so here the way we would do this is we would say unit, okay, we want to join the unit. And then you say, where do you want to join it? So you're going to say distance.unitID is equal to unit.id. And we're going to do the same thing for duration. And we're going to run it. Okay, so you see what the problem is. It says it's an ambiguous column units.id. And this is where aliased comes into play. So we need to aliased our unit. So we're going to go here and we're going to say unit, we're going to say distance unit is equal to aliased. So we're going to import that from SQLAlchemy ORM. And we're going to say unit. We're going to duplicate that and we're going to say duration. So what this does is it creates an alias for that table. So what we're going to do here is we're going to say distance unit, and here we're going to say duration unit. All right, and instead of using the unit, we're going to say distance.unitID is equal to distance unit.id, and here we're going to say duration unit.id. So now if we run this, our join is not ambiguous. So the way we're going to do this is, here we're not actually filtering by the miles and the minutes, but we can do it here. So let's go here. Let's organize it a bit. So we specified one clause here, but we said we can use and. Okay, so we're going to say and. All right. And here we can say, we can put a second parameter. So here we've got the distance unit. So what do we want the distance unit slug to be? So we can say this is unit dot slug is equal to miles. And we're going to do the same thing for our duration. So we're going to say end. Okay, we're going to open that. And then here we're going to say duration unit dot slug is equal to minutes. So if we run this, we get the correct result. So this is SQLAlchemy ORM Crash Course Part 2. I hope you have enjoyed this video, and if you have, please like, comment and share the video, as this helps the channel grow so I can keep making these videos. I upload new videos every week about Python and related frameworks, so if you want to get notified when I do, please subscribe as well as click the notification bell so you can be notified whenever a new video is released. Thank you for watching, and I'll see you in the next one.